Hi everyone, in this video we'll take a look at the economic and price side of things. My main goal with this project and with this multi-material upgrade was to reduce the price as much as possible. So I was aiming to make it at least lower than $300, which is the current price for the multi-material upgrade 2 from Charles Prusa. And I was also aiming to make it compatible with as many printers as possible, so as many FDM printers as possible. So in order to achieve that goal, I've made quite a few changes from the original Prusa MMU2, which my entire design and project is based on. So thanks a lot for making that entire thing open source. And all those changes are what we are going to take a look at in this video. So I've made a lot of decisions in this project to make it as affordable as possible, even if it was sometimes you had a downside, which was that you had a lot of assembly required, or at least more assembly required on the user side of things, which I think is not too bad because most of the people that are going to want this are hobbyists and people that like doing DIY stuff and working on 3D printers. So what I'm going to show you next is a price list. So all the components that I'm planning on using or that I might use to make you an idea of the overall price. So I'll have a range from the lowest price I could possibly get if I'm very lucky and if everything works as planned, and the highest price if I need to make everything, let's say, as overkill as possible. But in order for you to understand all those choices and different components that are in play in this project, we'll first take a look at how it works overall and the main differences that I'm already choosing to make compared with the original Prusa MMU2. Okay, so now we're going to take a look at the original Prusa MMU2. So if you've watched my previous videos, you will know that I've changed the color to better fit what this is. So Prusa and orange fit well together. So the basic principle is that you have 5 filaments coming in this way, so the 5 different colors or materials that you're going to be using, and then depending on the idler position, which is this part that has some bearings on it, depending on that position, a different filament is going to be pressed on the extruder and extruder gears. So depending on this position, a different filament is going to be pushed through and to the extruder. So now, once you have done your filament selection, you have 5 filaments coming out, but there's only one that you're using, and there's one that you want to bring to the extruder. So what they have done is that they use a carriage system, which selects what filament comes out. So that's the principle of how this works. You also have the direct drive extruder on there. So the multi-material upgrade is not doing, let's say, the heavy lifting, so it's not pushing the filament through the extruder. So now let's look at how many stepper motors you need to drive in order to make this work. So you have the carriage system, which is 1. You have the 2, so the extruder and the idler selector, so which makes it 3. Then you need to add the dual Z, which is on most printers for so the printer itself, so 5, and X and Y, which makes 7 stepper motors to drive. And if you also want a direct drive extruder, it's 8 extruders. So that's a lot of extruders to drive, and that's also why it's quite expensive. Okay, so now let's take a look at what is at the heart of this project, so all the electronics. So as you may know, a printer is driven by an electronic board, so your main board, which drives all the stepper motors and also decodes and uses the G-code. So right now on your printer, your board is most likely an 8-bit board, which has up to 4 stepper motor controls and very little room for expansion. So that's what it's going to be the case for most people. So I cannot do my project with that kind of board because A, I don't have enough stepper motor drivers, and B, everyone is going to have a different board based on the printer they use. So part of the cost is going to be the fact that you're going to have to buy a new board with enough extension to make the entire thing work, and also enough stepper motor controller to make it work. So I don't want to have a dual board setup so that the MMU2 has a board that controls it and that is connected to the main board, because this is going to add a lot of complexity and it's also going to drive the costs up. So the board that I'm going to develop this on is the Big Tree Tech SKR Pro V1.1, because it is a board that has the most expansion capability right now, I believe, and which is not too expensive. So it's still quite a hefty price compared to cheaper boards, but in our application it's going to do the job and not be too expensive and too much of a burden on the price. Now, this purchase won't simply be because your old board is not compatible anymore. This also brings advantages and is a legitimate upgrade compared to the board you probably currently have, for multiple reasons. So A, it's going to be most likely a higher quality compared to your previous one, but it is also 32-bit, so which brings some advantages. As you may know, you can have the drivers that you want, so your stepper motor drivers that you want. If you want to have like more silent one, more like better ones compared to the one, you can easily do that because they are swappable. So this board also gives you a lot of extension capabilities. So you can make your printer Wi-Fi compatible. You can have a touchscreen. You can have auto bed leveling sensors, and a lot of different upgrades. So for your printer. So this kind of upgrade, so changing to 32-bit main board, is done by people that don't even want the multi-material upgrade or that don't have any interest. So I think that this is definitely an upgrade and something that should be taken into account when speaking about cost, but it has a very big upside next to it, which is that it's an upgrade by itself. Okay, so now let's take a look at the modifications I've made to the MMU in order to have it at a lower cost. So if you've watched my previous videos, you may know that I've modified the idler shaft quite a bit. So the barrel with the different bearings on it. So it has 625 bearings on it, which are 16 millimeters by 5 by 5, I believe, something like that. And they are a bit smaller than the 608 bearings. So I've redesigned the idler shaft in order for it to fit 608 bearings, because these 608 bearings are less expensive and also more widely available, which is extremely important right now during the COVID-19 crisis, because I was absolutely unable to find any 625 bearings below like $4 per bearing, when you can buy 608 bearings. You can buy 10 of them for a few dollars, so it was a big improvement price wise. The next modification that's made is one of these examples where you reduce cost, but you add a bit of assembly and work on the user side. So as you may see, there are little inserts, so metal inserts to keep the bearings in place, and I've made it all 3D printed, and you simply slide the bearings onto it when during the print, because it is a layer by layer process. So you slide the bearing in, then you continue the print, and the result is cleaner, requires less parts, so it's cheaper, and works very well overall. So I've also adapted the idler body and the different parts so that it would fit everything. And yeah, that's about it for the idler side. Okay, so now let's get into the main issue that this entire thing has, and it is the number of motors that you have to drive. So let's make a quick count. You have 3 on the multi-material upgrade, and you have 1, 2, 3, 4. So 3, but most likely 4 on your printer, because some printers don't have dual Z. But I still want to be able to keep that dual Z to make it work with as many printers as possible. So you have 4 motors that you need to drive on your printer, and you have 3 motors that you need to drive on the multi-material upgrade. So that makes a total of 7 motors. So you may notice that this is exactly the number of motors we can drive with the SKR Pro board. And you may also notice, but wait, you have not counted the right number of motors on your printer. And yes, I haven't counted the extruder motor. So if you take the stepper motor, so the extruder motor into account, I cannot drive the this entire thing with a single main board, and this would increase the price a lot. Because as I said before, or maybe not, but I'm planning on using the MMU2 as an extruder itself. So not having an extruder motor, but use this entire setup as an extruder, and this is gonna work exactly like a bone tube setup. So I'll just need to be sure that I have a motor with a sufficient torque on the gear side of things, and I should be good. So that means that we can control it. But now I have an additional, let's say, trick, and it is that this entire carriage thing is complex and has a lot of parts, and also costs a lot, and it takes up one of our motors control, which you may have noticed are really important, and we have few of those. So I think that we can just remove that entirely. So if you've seen my previous videos, that's what I'm going to do. So I'm going to use a merger instead of selecting the specific filament, and this is going to help reduce costs, and this is going to give us an extra motor to work with. So now what can we do with that motor? We have 2 options here. A, we don't use it, which means we only need to drive 6 motors. So we can use all the boards that have that can control 6 stepper motors. So that means that we can use a lot of boards, and we can use boards that have 5 motor controls. Yes, 5, not 6, because if you split one to have dual Z, you can have a 5 motor control main board, which means that you will have a lot more choice, and it will also be cheaper. Now you have a second option, which I think is going to be the best one, and it is to use that last motor to work as a direct drive extruder. So this is going to be really helpful if you want to use flexible filament, and and if you want to have something that works very similarly to the MMU2 from Joseph Prusa. So what I'm going to do right now in the project is that I'm going to first develop when using only 6 motors, so using the MMU upgrade, so as an extruder and as a Bowden tube setup. And if this does not work, I will have to go to the direct drive setup, because I want to make it as cheap as possible. So I'll first work on using this as a Bowden tube setup, and then I will work on the direct drive setup. Okay, so now let's make a list of the parts that we're going to do, and also how much they're going to cost, and look at the more optimistic price and at the let's say more pessimistic price. So depending on whether we have to do the Bowden tube setup, or whether we also have to add a direct drive extruder in order for it to work properly. So that will depend on how it works. I cannot tell you that right now, but I can tell you the lowest price that we may reach, and also the highest price that this entire thing is going to cost. So let's get into it. Okay, so first the motors. So you may think that you need at least 2 of them, so for the multi-material upgrade, but you actually only need 1, because on the printer that you already have, there's actually a motor that you are no longer going to be using, which is your extruder motor. So since we are not going to be using that one, you can reuse it on the multi-material upgrade. So personally for me, I'm running a bottom tube setup, so this motor is simply going to be used to rotate the idler, for example. So you only need two motors if you're running without the direct drive extruder, so if the bottom tube setup works, so to say. And if it doesn't, in that case, then yes, you're going to need two motors, but that's going to be the maximum number of motors that you're going to need if you actually reuse the one that you already have on your printer. Okay, so next up are the bearings. You're going to need at maximum, let's say 20 of them, so that's the number I've chosen to work with. So you will first up need 5 of them for the idler, but you're also going to need some of them for the spool holders, because you know that you're going to be using 4 spools. So if I use a similar design like that here, there's going to be like 4 bearings per spool, and this can add up very quickly. So I will try to find a way to use less than 20 bearings so that we can keep the price nice and low. Okay, so we then also need some extruder gears. So you will need 5 of them, so 1 for each filament, but they usually come in pack of 10, so that's what we are going to be using for the pricing. With those, you're also going to need a metal rod. This one was pulled from a printer, so I hope yours is a little bit cleaner, and I also have ordered some clean ones which are going to be on the way, so the price of the new ones will be included as well. So with that, you're also going to need some stepper motor drivers. I've chosen to go with the A49AA drivers, which are quite inexpensive. So you will need at least 6 of them, but I've taken 7 of them to fully populate the board. With that, I've also chosen to add Wi-Fi capabilities to my board. So I've bought a small ESP module, but we won't count that into the price because this is not necessary. Just something that I wanted to add. Okay, so then you're going to need 5mm to 5mm coupling to connect the metal rod with the extruder gears on it to the stepper motors. So these coupling are quite inexpensive, they come in pack, so I will take the price of a pack of 3, which was what I used. You will then need a simple switch that we will use as a filament sensor. So these are really inexpensive, and this is a way cheaper option than the inductive sensor, which is on the original Prusa MMU2. You will then need some filament in order to print the part itself. You will also need a few screws to assemble everything. And then we will take a look at the parts that I haven't received yet, which are currently shipping, and talk about them. Okay, so these are the products that I still haven't received. So a screen, I've bought a touch screen. This is one of the more premium options that you could get, so a bit more expensive. We will still keep that. Of course, the SKR Pro from Big Tree Tech as the main board. Then I've bought a few 5mm rods and the stainless steel threaded rod, which I will most likely not need since I've chosen to remove the carriage system, so we don't need to take that into account for the final price. Okay, and now we can see that we reach this $121 to $136 figure, which is great when you compare it to what is already out there, so the palette or the original MMU2, which are at least twice the price. And yes, the maximum figure of $136 may be a bit low because you will need to do some adaptations. If your printer is a button tube printer, you will need to adapt it in order to fit a direct drive extruder. But this will vary depending on your printer, so $106 I think is a good idea because people that have a button tube printer may not necessarily need the upgrade, and for the people that already have a direct drive printer, this is what it will cost him. Now the minimal price may even be a bit lower than that, because you don't necessarily need to buy the SKR Pro and that many stepper drivers. So I needed to buy like 10 because they come in packs of 5, and you could only buy 5 if you decided to not go with the direct drive solution. But I prefer to have that minimal price, which may be a bit higher than what it will be in reality, so that we have a bit of let's say space to add a few things or improve some things depending on how well it performs. Okay, so thanks for watching, and I will see you guys in the next video, where we will be probably talking about like the overall physical assembly, which I will try to finish in the next days, because we have all the parts but they are still separated, so to say. I have to find out how they will all fit together and how we are gonna mount it on the printer, and take all these pieces and put them together so that we can have the at least physical product finished, and that we can start with the programming and adapting the Marlin firmware in order for it to work.